In this video, we are going to learn how to apply the chain rule. Okay, so the chain rule says that if y is a function of u and u is a function of x, then the derivative of y with respect to x will be dy du multiplying du dx. So that's what the chain rule says. Let's take an example for a better understanding. So let's say we have y to be equal to x divided by 3x plus 2 all to the power 5. Okay, so this is y here. So now you have to find the derivative of what? This function here. But from the definition, you see that what y is a function of u. Okay, what that means is that you have to express y in terms of what? U. Okay, so to do this, I'm going to let u be equal to x over 3x plus 2, right? So you can write y as y equals u to the power 5. Okay, I just did substitution here. So now we know y expressed in terms of u, and then we know u expressed in terms of what? X. So now let's apply the chain rule formula here. So to do this, you will need dy du. Okay, dy du. We are going to apply the power rule here. So we are going to have 5u to the power 5 minus 1. That will give us 5u to the power 4. But we know u to be what? X over 3x plus 2. So that will be 5 multiplying x over 3x plus 2 to the power 4. So that's what dy du. Now let's find the u dx. So we know u to be equal to x over 3x plus 2. Okay, so I have to find the u dx. To do this, I'm going to let a be equal to x and then b be equal to 3x plus 2. Okay, so I'm doing this because I'm going to apply the quotient rule here. Okay, so let's look at that. So let's see if we have a function f of x, okay, which is equal to a of x divided by b of x, then f prime of x, okay, will be equal to b of x multiplying a prime of what? X minus a of x multiplying b prime of what? X. All this divided by b of x, okay, squared. B of x squared. So it's just the quotient rule that I'm applying here. So what you need here is a prime and then b prime, right? So the same thing that I'm going to apply to find du dx. Okay, so let's look at that. So now from what you have here, a prime will be 1 because that will be the derivative of x, right? And then b prime will be 3 because the derivative of 3x will be 3 and then the derivative of 2 will be what? 0. Okay, so it's just the same thing that we are doing here. And of course, you see that this a and b are functions of what? X. So now we know a prime and then b prime, right? So we are going to have du dx, okay, to be equal to b, okay, multiplying a prime minus a multiplying b prime, all divided by what? B squared, right? So let's do the substitution. So we know b to be 3x plus 2 multiplying a prime, which is what? 1, okay, minus a, which is x, multiplying b prime, which is what? 3. All this divided by b squared, okay, which is 3x plus 2 squared. So let's do some simplification. You're going to have 3x plus 2 minus what? 3x, okay, divided by 3x plus 2 squared. So this minus 3x will cancel out this 3x, and I'm going to have 2 divided by 3x plus 2 squared. So now let's do some substitution here into the general formula. Okay, so we now know dy du, and then we know du dx to be equal to 2 divided by 3x plus 2 squared. Okay, so now let's go ahead and then do the substitution. So I will free up some space so that we can continue. Okay, so now let's go back to the general formula. So we have dy dx, okay, to be equal to dy du, right? But we know dy du to be 5 multiplying x over 3x plus 2 to the power 4, okay, times du dx, right, which will be 2 divided by 3x plus 2 squared. Okay, so now let's simplify this here. In simplifying this, multiplying, okay, let's square these brackets first. Okay, when I square these brackets, you're going to have 5 multiplying x to the power 4, okay, divided by 3x plus 2 to the power 4, okay, times 2 divided by 3x plus 2 squared. Okay, this is what you are going to have. So we can further simplify this to 5x to the power 4 divided by 3x plus 2 to the power 4 multiplying 2 over 3x plus 2 squared. Okay, so now multiplying 5x to the power 4 by 2 gives us 10x to the power 4, okay, divided by 3x plus 2 to the power 4 multiplying 3x plus 2 to the power 2 gives us 3x plus 2 to the power 6. Okay, so that be the derivative of that function. So for a better understanding, let's try our hands on one more example. Okay, so now let's try this example here also. We have y to be equal to the tan of 4x squared, 4x squared minus 3x plus 1. Okay, so this is our y here. Okay, so you have to find the derivative of this function here. So to do this, we must first express y in terms of u. Okay, so I'm going to let u be equal to 4x squared minus 3x plus 1. Okay, and then from there I'm going to have y to be equal to the tan of what? U. Okay, so y will be equal to a tan of u. So now we know y expressed in terms of u and then u expressed in terms of what? X. So let's differentiate these two functions. So dy du, okay, will be equal to sec squared u, okay, because the derivative of tan is what? Sec squared. Okay, so if y equals tan u, then dy du will be what? Sec squared what? U. Okay, so let's take note of that. Okay, so we already know that u equals what? 4x squared minus 3x plus 1, right? So this will be equal to sec squared of what? U, right? Which will be 4x squared minus 3x plus 1. Okay, so this is what we have now. So now let's find the u dx. Okay, we know u to be 4x squared minus 3x plus 1. Okay, so the u dx, okay, will be equal to 4 multiplying 2x, right? Because I applied the power rule to what we have here. Okay, okay, minus what? 3. And then the derivative of what? 1 is what? 0. So simplifying this, you're going to have 8x minus 3. Okay, 8x minus what? 3. So now let's apply the chain rule. So we're going to have dy dx, okay, to be dy du, which is what? Sec squared of what? 4x squared minus 3x plus 1. Okay, multiplying du dx, which is what? 8x minus what? 3. Okay, so that'll be the derivative of that function. Okay, so let's try one more example. Okay, let's try one more example. Okay, so for this example, we have y to be equal to tan x plus sine x. Okay, all to the power minus 3. So this is y here. So the first thing you have to do is to express y in terms of u. Okay, so I'm going to let u be equal to tan x plus sine of what? X, right? So y will be equal to u to the power minus 3. Okay, so we now know y expressed in terms of u and then u expressed in terms of what? X. So we can find dy du. Okay, and then we can apply the power rule here. We're going to have minus 3 multiplying u to the power minus 3 minus 1. That gives us minus 3 u to the power minus 4. Okay, I can write this as minus 3 divided by u to the power 4. Okay, so now we know u to be what? Tan x plus what? Sine x, right? So this will be equal to minus 3 divided by tan x plus what? Sine x to the power what? 4, right? So now let's find the u dx. We know u to be tan x plus sine of what? X, right? So the u dx, okay, will be equal to the derivative of tan x will be sec squared x, and then the derivative of sin x will be cos x, so plus cos x. Now let's do the substitution. We're going to have dy dx, okay, to be equal to dy du, which is minus 3 divided by tan x plus sin x, okay, to the power 4. Okay, multiplying the u dx, which is sec squared x plus cosine of what? X, right? So further simplifying this, we're going to have minus 3, okay, multiplying sec squared x plus cosine of what? X, right? All this divided by tan of x plus sine of what? X, all to the power 4. Okay, so this will be the derivative of the function that was given. Thank you very much for watching this video. Please make sure you like and subscribe.